Okay, I'm starting over because I ruined it by putting the thing under there. So this is what we're working on, side angle side. And we're going to work on proofs. Okay, let's write this down. Go ahead and put examples. It's a good idea to put little example triangles here. Okay, the annoyance that we did the other day where we had to write 3 angles and 3 sides would take forever to do a proof on. And so there's different proofs coming from theorems that we're going to do here. And order matters, just like with the congruent statement, order is going to matter with this as well. Okay, and so I'm going to write my little congruent statement about these guys, and that's basically what is going to matter. I'm going to copy just like the book, and I want you to do that too. I'm just going to use different colors. So the congruent statement, so triangle A, B, C is going to be congruent to A goes with D, B goes with, well, B and A share that line, so B will go with E. A and C share the double line. D and F share the double line, so this is what it will be. And I realize it's kind of at the end of it. There we go. So side angle side. We're going to use this to do some proofs. Okay. So this is basically going to be the last step in your proof. And I didn't finish writing what this is. It's a congruence theorem. All right, so side angle side congruence theorem. We're going to abbreviate by saying SAS. So that's going to be our last step. So before we do easier problems, we're going to do some sample proofs. Okay? There's going to be some easier problems too, but let's go ahead and do some sample proofs. All right, so I'm going to put this on here, and I'm probably going to have to zoom out so it will fit on the page. And I want you to set this up like this, and it's going to take you a second to write it down. There will be, but we're going to do 2 separate problems. And so I'm going to do this problem, and then there's a separate problem. And I pre-did it just so we could, maybe not watch me draw the problem out. I know as exciting as it is to watch me draw out a problem. So it's important when you start these problems that you have a shape, and we're going to do something with that shape. And then you're going to have a given that the book is going to give you. And then you're going to have what you're supposed to prove. And what we're going to prove most of the time is going to be some triangle is congruent to some triangle. These are all congruency proofs. And these are nice because they're not super difficult. That being said, it's really hard until you understand it. For the most part, they're going to be between 3 and 5 steps. There are other proofs in your book that might be 8 to 10 steps. We're going to focus on the ones that are 3 to 5 steps right now. And I have all kinds of worksheets that have easier stuff. I have all kinds of stuff that we'll be doing. We're going to be doing this for a while. But today we only have one rule. I'm going to show you how to do this thing. And I like to do this with different colors just because I get so used to looking at the book. And the book always uses red to kind of mark up the shape. And so I like to do the same thing because I just visually get used to that. When I give you worksheets and they're in black and white, it's not as good. It's harder to see what's going on. That's why we try to do as much book stuff as possible. Okay. I'm going to go ahead and get started here. And I think you already know what is the first step that I'm going to do. I'm just going to write the given. So even though I wrote it up here as the problem, I'm still going to, as the argument, as the proof, I'm still going to have to write it right here. And so I'm going to do that. And I like to use two separate lines. I did a bad job on that. All right. And so I'm going to write given for that. That's fine. And I'm going to mark it on my shape. BC is congruent to DA. Okay, that means BC is congruent to DA. Is that correct? Okay. Next thing I'm going to write is BC is parallel to, well, it says AD. That's fine. All right, so I'm going to mark that on my shape. And the book usually marks it with a little triangle like this, little triangle like this. That means parallel. Okay, I will try to correct the crookedness. All right, I'm going to come up with a plan. I wrote a little plan right here. And the plan is this. Okay, I know that's the plan because at this point, I only have one ending to the proof that I've gone over, and that's SAS. Eventually, you'll have 6 endings. Right now, you'll have 1 ending. So I know it's going to be side angle side. So what I need to prove is I need to prove that both these triangles have a congruent side, a congruent angle, and a congruent side. I know right off the bat with this given right here, that gives me a side, doesn't it? That gives me the side BC and DA. So I'm going to go ahead and put a check mark that I have one thing I need already. And so now I just need an angle and a side. Okay. Well, the angle might be hard, so I'm going to go ahead and do a side. And this is something that you might not know. I said that once we deal with triangles, we're going to understand it. But I'm going to mark this shape. I think that AC is AC on both the triangles, AC and CA. I think that AC is congruent to AC. Do you remember what rule that would be?
Reflexive?
It is correct, reflexive. Okay, this is the purpose of the reflexive property. Okay? Both triangles share this side, and so I can say that those sides are congruent because of the reflexive property. And basically they both share a line, and so the reflexive property allows me to make this statement, and it allows me to go over to my plan and say that now I have a side and another side. Now all I need is an angle, right? Okay, and I'm going to look up at the shape. I really want to figure out a way, because to do side angle side, I need this angle to be equal to this angle. That's what I need. It can't be this angle, and it can't be this angle. It has to be the angle in between the two sides. That's why it's written this way, side angle side. So basically, each side is part of this angle, yes? Mm-hmm. If I pick this angle, only one side would be part of the angle. Okay? And so I'll kind of go over that in a little bit after we do this proof. So now I'm going to look at my given. Okay? I used this one already to get this side. This one got this side. I bet you that they gave me this parallel line thing to help me come up with the angle. So I don't know what to do, but I probably know that this problem is going to work out because Mr. Crowder gave it for your first problem, so it has to work out. I wouldn't give you a trick. So I bet you that angle CAD is congruent to, so CAD is congruent to angle ACB. And if only I knew something, some kind of vocabulary or theorem that would tell me what those angles are. Someone suggested that they're alternate interior angle theorem. Then I would have my final thing right here, my angle. Is she right? Is that true? Are those alternate interior angles? Are alternate angles equal? So that's my third thing, and so my final statement is this. Triangle A, B, C, C, D, A. And the reason is okay, what we have just completed is an argument, a mathematical or a logical argument proving that these two triangles are congruent. Okay, the applications of this go way, way beyond geometry. But basically, if you can't argue, if you can't prove me wrong on this point, and you can't prove me wrong on this point, then that means you have to accept this point. And that's kind of how, if you went to court, you know, that's how it works. You have to argue the different points, or you're going to win. Yes, question.
Yes. How did you find the angle again?
How did I find the angle?
Yeah, in SAS, how did you find the angle?
Well, we found the angle. We knew that the angle I wanted to do SAS is going to be in between the two sides. And we knew that parallel lines has some vocabulary like alternate interior theorem, and that's how we proved that it was equal or congruent.
Another one?
Well, I'm glad you asked because we do have another one. We're going to do several, and we're going to go slow because I do not expect anybody to get it right away because you've never done anything like this. Even the algebraic proofs we did, I made you do the segment addition postulate one, but that still was just one geometric thing. The rest was algebra. So here's the next one, and I guarantee the plan again is going to be SAS because you don't have any other options at this point. So just make sure you know that. So the given R is the midpoint of Q, S, and PT. I made that kind of small. And I'm also going to put this on a video, so if you need to study and kind of go over this, or you miss some days, I'm going to put all the proofs I do in class on video.
R is the midpoint of...
QS and PT. Unfortunately, I should have wrote it a little bigger. And I should have wrote that as a capital T, but I didn't.
What's the proof?
What's the proof? It is triangle PRQ and TRS. So in this one, I know the beginning. I know the beginning is given, and I know the end. The end is going to be SAS, and it is going to be this. Okay? I know that before even starting the problem because I don't have any options at this point. Eventually, the end will have 6 different options, but for now, I know the beginning and I know the end. I just have to prove this end. And that's the same thing in And I always relate this to being a lawyer or making a logical argument, is when you're a lawyer, you know the given is all your evidence, and the end is what you want, right? You want to win, whether it be criminal or not. You want to prove someone guilty or prove somebody innocent. You know the end, you know the beginning. You got to fill in the details where people can't argue with you. Okay, R is the midpoint. I got a problem with words. We don't know how to do math with words. Okay, so I'm going to have to teach you how to do math with words. Which the secret is you don't. You have to do something else. R is midpoint of QS. And I like to separate it because I'm going to use both of these things. Because I'm sure that both of these things are going to be important to me. This is my given. And a lot of times, if I'm going to do a given like that, I'm going to draw a little line here, just so I see that category. Okay, I don't start with anything. I know I'm going to need two sides and two S's. So I see a word. Anytime I see a word, I'm betting that the definition of the word is going to somehow give us something. So what is the definition of midpoint? It's the point in the middle, right? Do you remember when we did the definition of midpoint? It was real easy. We had a point that was in the middle, and then the two line segments were, I'll skip a line, PR, well, let me do the one that comes first. So QS, okay, do you think that's true? If R is the midpoint, do you think that this is going to equal this? Isn't that what we discussed earlier? That the midpoint divides it in half? So that means QS, QR, and RS is congruent. And that would be the definition. Okay, I think that's what our book had. Okay, does that give me one side? Let's see if you can do the next one. I have two of them. I only used the first one. See what you can do with this one. Okay. Do we think this is true? And why? Definition of midpoint. We could write it again, or we could just kind of box it off there. I'm going to write it again just because. So anytime you have a word, there's sometimes a theorem that goes with it, but sometimes it's just the definition. And in this book, I don't think we had a theorem for this. I'll double check. Probably should have wrote that in a different color other than red. All right, so this would be side and side. Okay, which angle do I want? Do I want this angle, or this angle? Which one's in between the two sides? This one right here? Okay, so to use this theorem, I know that I want angle P, R, Q to be congruent to T, R, S angle. Okay? Is there anything, any kind of theorem? What do you got?
Of the
This would be the vertical
angle theorem.
angle theorem. Okay, right? These are some of the theorems I said we're going to use forever. So that gets me the, right here. That gives me angle. Can we finish up what we do on this one?
Basically write down the proof you need.
I basically just write this. What I've proven, P, R, Q, congruent, T, R, S, and I'm going to write S, A, S. Okay? So I came up with my plan, and I proved the side, I proved an angle per side, and so that finishes it up. Okay. So that's basically what we're going to do. There's words that we're going to use a lot. We just used midpoint. Okay. This is not part of this proof. So what does bisect mean? Anybody remember what bisect means? Doesn't that cut in half? Okay, so if you use the word bisect, it can create either two congruent lines, segments, or two congruent angles. Okay, so you might need that. Reflexive property we'll use. And yeah, I think you're ready. Okay, so go ahead and go to 225. And we are going to start. Yeah, we got time. Well, let me actually go through some planning here. Yeah. Yeah, we're gonna start with some problems before we do the proofs. Let me show you. We're on page 225. The first part of it is pretty easy, but you might not understand what that do. So that's a problem if you don't understand what to do. So wow, those triangles are terrible. So yeah, I can't even deal with those triangles. They're so ugly, too ugly. I messed up the angle. Here, let me draw off screen. Okay, this is better. It's not exactly your book, but it's better. So K, J, L, P. So number 3, it says to name the included angle between the pair of given sides. So this is JK and KL. So JK is here. KL is here. So what angle is in between those sides? J, K, L. So I noticed something. You see how they both share a letter? That's the vertex. Does that make sense? That both lines start from the same point. That's what's important about this. So we're going to do 3 through 8. Okay, and I'll tell you the biggest thing that we have here is we have two problems. We have SAS, and we are going to have some of these problems in 9 through 14 that are this. Okay? This means that the angle is not in between the two sides. This is not ever going to be one of our endings. Okay? If you would spell this backwards, it would spell a bad word, right? Okay? So just make sure that almost every other combination works. This combination doesn't work. And so we can look at number 9. And I'm going to show you an example of what I just did. Look at number 9. It says, decide whether enough information is given to prove the triangle are congruent using SAS. Okay, I'll freehand this just for speed. Okay, which means it's not as good. This is number 9. I'm going to mark it up. Okay? So I'm looking at this. I don't have side angle side. I just have a side and angle. But I do know reflexive property right here. Okay? Does this work? Okay? The first thing I notice is this angle in between the two sides. And this is how you can tell. You can start here. Side, I'm just tracing. Side, that would be an angle, side, and now my angle's outside of it. This is the angle that I want. This would be a case of the SSA. So this does not work. This is not part of the congruence theorem. Okay? So be careful about that. So yes, you can do this, but if the angle isn't in between, if the end point of the two lines is not the vertex of the angle, it does not work. This angle would work and this angle would work, but the ones they give me doesn't work. So basically what I want you to do here is to follow the directions on the thing.